Hey everybody, this is Larry. This is one of the prompts I saw for the bi-weekly contest 29. I'm gonna put the explanation in the beginning, and then I'm gonna do the live coding of it afterwards. Let me know what you think about this format. I'm still playing with it, and here we Q2, the K factor of n. So this it could have been interesting, but this is because n is less than 1,000. You only have to do a linear search to count all the factors and then return the first k element or the kth element with a bound check that if it doesn't have k elements, then it's return -1. So you can actually also do this in square root of n times by just go up to the square root of n to count all the factors. So that is also another way, but because n is equal to 1,000, I didn't even have to think about it. So this is O of n times, which is not linear per se. It's just O of n times. Cool. And this is just brute force for that reason. You could go to square root of n, and then if you check the square root of n, then you get two factors, right? X and n over x, and then you can put it in an array and either sort it or just keep track of it as it goes toward the middle. And there's just an edge case about the square root, but otherwise you could do it in square root of n times. Relatively straightforward, but yeah. 2, the k factor of n. So this one, the first thing I looked at after seeing this is kind of look at the constraints of n and k. Well, when I saw that n is 1,000, then I was like, okay, well, let's just do a brute force. I don't have to. So there was the square root of n one, but it's a little bit trickier. Not that much trickier, but a little bit trickier. And yeah, and basically I just do a brute force and just check all the factors, put in a list, and then return the k factor. You don't even have to put in a list actually, but I put it in a list, and then you just kind of check it.